So, Robert, we've been talking about writing clean code internally. But what about when you have to work with code from other teams or third-party libraries? How do you maintain that cleanliness?
Yeah, that's a crucial point. We seldom have complete control. Often, it's a mix of our own code and external code.
So, you're saying clear interfaces are key?
Exactly. Well-defined APIs are essential. They act as the wall between the different sections, preventing spaghetti code.
Can you give an example?
Think of an external library, maybe a payment gateway. We need to integrate that. The library has a specific set of functions for processing payments.
So, we make our code use those functions through their interface.
Right. And if that interface changes, we ideally re-implement the adapter layer rather than directly modifying the library code itself.
Makes sense. Is there a best practice for testing this kind of integration?
Absolutely. Unit tests for the adapter code. Integration tests to verify the whole system works as intended. Crucially, don't just test the input. Test the responses too.
So, unit tests on the adapter code, and then integration tests. Got it.
You see, thorough testing, like that, is crucial to avoid nasty bugs.
What happens if the third-party library updates?
The ideal is that the adaptation layer handles the updates. This avoids ripple effects in our own system.
Wow, that's really interesting. So we should always try to keep things independent, using adapter layers.
Exactly. It keeps everything clean and manageable.
Great insight. Thanks, Robert.
Anytime, Andrew. It's all about maintaining good boundaries in the software landscape.
So, Robert, you're saying that just handing out a map object like java.util map is a bad practice?
Yeah, precisely. It's like giving someone a Swiss Army knife with every possible tool, when they only need a screwdriver. The extra power is a liability. Changes to the map interface could break code all over the place, because it's not tailored to the application's specific needs.
So, what's the solution?
Encapsulation. Wrap the map usage inside a dedicated class, and design the interface only for the client's needs. Our sensors class is a good example. It handles the internal map and exposes only what the application needs. That's crucial for maintainability.
But wouldn't it be more efficient just to use the generic map instead of writing a wrapper?
Efficiency is often traded for maintainability. Imagine a large system, and the generic map gets a new method. All the places where it's used will need to change.
So, you're advocating for more specialized classes?
Absolutely. It's about clear separation of concerns. The sensors class now contains all the knowledge about how sensors are handled. You know exactly how to deal with it.
So, how do you know when to wrap and when not to?
That depends. If the map is only used within a limited scope, within a class or a small set of related classes, you don't necessarily need to wrap it. But if it's passed to external components or public APIs, that's when wrapping becomes crucial for managing ripple effects.
Okay, I get that. What about, real-world examples?
Immagine a social media platform.
If the user data is a map, changes to the structure could affect all places the user data is used. Encapsulation can prevent this problem.
That makes sense. So, you're arguing a balance between flexibility and maintainability.
Yes, you want to be flexible, but you don't want a sudden explosion when there's a change.
That's great, Robert. Thanks for sharing your insights on clean code principles. Robert, you mentioned earlier the importance of writing efficient code. But integrating third-party libraries often feels like a black box, right?
Absolutely. There's a trade-off between getting something working quickly and understanding it thoroughly. Sometimes, the documentation is thin.
So, what's the balance? Should we just dive in and try things out in our actual production code?
You could, but it's risky. You might spend a lot of time debugging issues that aren't in your code.
So, what's the alternative?
Learning tests. You write tests to explore the API before you integrate it into your production code.
Learning tests? Sounds a little like overkill.
Not necessarily. Imagine you're working with a social media API. You'd write tests to call the API, checking for correct responses, handling errors, and understanding the format of the data.
But how are these different from regular unit tests?
These tests are focused on your understanding of the third-party API. They don't assert how your code interacts with that API. They are to verify if you grasp the API correctly.
Okay, so you're saying we essentially treat the third-party API as a module and unit test it first?
Exactly. You're exploring, verifying, and making sure you know what it's doing. This way, you're less likely to get stuck later.
That seems very thorough.
It's about thorough understanding. If you're spending a long time debugging an issue later, those learning tests can save you lots of headaches.
Great point. So, you'd write tests to call the API with different inputs and verify expected outputs?
Yep, making sure you're understanding the API, like a developer doing controlled experiments.
And how do we do this practically without slowing down development?
You could use mocking or stubs to simulate the API, avoiding the need to call the real thing for every test.
Ah, that makes more sense. So these aren't production tests. They're like investigative tests, so we understand the black box before we bring it into the main system?
Exactly, making integration safer, faster, and less error-prone.
Appreciate the clarity on that. Thanks, Rober. Hey, Robert, great to have you back. We've been talking about clean code, and now we're diving into Log4j.
Glad to be here. Log4j is a powerful logging library, but it can be tricky to set up correctly. Let's dive in.
This example shows tests for different configuration scenarios. Why is it so important to configure the appenders?
Well, imagine you have a system that logs information to a file, but that file isn't configured correctly. You might miss crucial error messages, leading to bugs that you don't find until much later. These tests show how to correctly route the log messages to the console.
Ah, so those at test methods are checking different configurations for Log4j?
Exactly. You're testing the proper setup, verifying that logging works. The unit tests also show how to deal with that unconfigured issue with the default console appender.
So, if it's missing an output stream, that means there's nothing to write to.
Correct. The setup of the output stream is crucial for correct log handling.
This pattern layout is interesting. Is it formatting the log?
It's like a template engine. It lets you format the log message with placeholders like the log level, timestamp, and message.
So, these unit tests are just verifying the setup rather than the log messages themselves?
You're right. You're testing how the configuration is used to correctly route the messages.
Makes sense.
A good logging system should be flexible and extensible, not only to console but to files and databases as well.
It seems like understanding the basic configuration is key to preventing errors.
Exactly. Good code design includes testing for different conditions and configurations. The tests here demonstrate that principle.
Thanks, Robert. This is really helping me understand.
You're welcome. Let's keep going and dive into other types of appenders.
Sounds good. Rober, learning tests. Fascinating concept. Are they really that helpful?
Absolutely. They're essentially experiments to understand an API. You learn its nuances through controlled interactions, and that knowledge is priceless.
So, you're saying that these tests aren't just about checking if something works, but about understanding how it works?
Precisely. And that understanding is invaluable when third-party libraries inevitably evolve.
But isn't that a lot of extra work?
Well, the benefit is in proactive problem-solving. You're not just fixing bugs, you're anticipating them. Imagine a new version of a library, adding a feature you didn't anticipate. Your learning tests will catch any compatibility snags quickly.
I see. So, learning tests help with compatibility, but what about transition between versions? Do you use boundary tests there?
Exactly. Boundary tests are like the bridge to get you from one version to another. You've got this clear interface between your code and the library, and those tests ensure you're not surprised by subtle changes in behavior. They help you migrate without headaches.
A good analogy. What are some practical examples of when these tests would be especially useful?
Databases. Libraries that you integrate into your code base. Imagine integrating the latest version of MongoDB with your application. Learning tests check what it does. Boundary tests make sure it acts as your interface expects it to.
I get it. So, learning tests are like experiments in the library, and boundary tests are like ensuring the smooth transition to a new library version? Makes sense.
Yeah, it's a proactive approach rather than a reactive one. You're testing beforehand.
So, How often should we update learning tests for a constantly evolving library?
That depends on the rate of change in the third-party library. If it's stable, you might only need to run them occasionally. But if the library changes frequently, you might need more frequent updates.
Interesting. Thanks, Robert. Very informative.
You're welcome, Andrew. Glad to share the knowledge.
Makes a lot of sense. Thanks. So, Robert, you're saying that even when you don't know everything about a piece of software, you can still create a robust interface?
Absolutely. Think about a new feature in a game, or a new piece of hardware you're integrating. Sometimes you just don't have the complete API.
So, you're saying to just guess the API?
Not guess. You proactively design a placeholder interface, like a contract for what you expect the future API to provide. This interface keeps your code clean.
Okay, but what if the real API is completely different?
Well, you've got your adapter. A simple adapter handles the translation between your expectations and the actual implementation when it eventually appears. So you build to what you want the API to be, even if it's not what you have.
That makes sense. How can this approach reduce project risk in situations where requirements are unclear?
Defining your own interface acts as a safety net. It gives you flexibility to adapt to changing requirements. You're not tied to a single, potentially incorrect vision of the system.
This seems to require significant foresight. How does this scale to larger projects?
It definitely needs good planning, communication, and a commitment to good coding practices within the team. The crucial aspect is that everyone is on the same page about this interface.
So, this means you're basically decoupling different parts of the system?
Exactly. Your code becomes much more modular, easier to test, and less prone to breakage when the unknown parts do evolve.
What about performance? If you have to translate through an adapter, won't that be slower?
In many cases, the overhead is minimal. The key is to make the adapter efficient.
That makes a lot of sense. So, it's really about building for flexibility and adaptability?
Yeah. You're designing for the future, not just the present.
Great. This is a really valuable insight.
You bet. It's a key principle in creating clean and maintainable software.
Thanks for the lesson. This will be great for my current project. And so on. Hey Robert, so, clean boundaries in code. What exactly are we talking about here?
Think of it like a wall between your code and some other system, like a database or a payment processor. You don't want your entire codebase knowing the intricate details of that third-party system.
Right, so, keep things separated. But why is this important?
Well, imagine that third-party system changes. Suddenly, your code might break. Clean boundaries mean your code is less tied to those external dependencies.
So, you're advocating for wrappers and adapters?
Exactly. Wrapping gives you an interface that's more tailored to how your code expects data. Adapters transform the output from the external system into a usable format for your code.
How do these wrappers protect us from unwanted change?
Well, your code directly interacts with the wrapper, not the complex external system. If the external system changes, you only have to modify the wrapper itself, not rewrite huge chunks of your application.
Okay, so you're saying wrappers/adapters make the code more maintainable.
Definitely. Fewer things to change when the third-party code changes, and it makes your codebase more robust in the long run.
But aren't wrappers sometimes overkill?
It depends. Sometimes, adapters might be more elegant for simple transformations. It boils down to the complexity of the external system.
Interesting. Any real-world examples?
Sure. Think of a library using a payment gateway. They don't need to know all the payment gateway specifics. They just use the wrapper.
Good point. So, when do you know to use a wrapper or an adapter?
If the external system's interface is complex, an adapter might be better. If it's fairly straightforward, a wrapper might be enough.
That makes sense. Thanks for the insights, Robert.
My pleasure. Let's dive into specific use cases next time.